When the Space Shuttle program ended in 2011, it marked the close of a legendary era in American spaceflight. For decades, the shuttle had been the symbol of U.S. ambition and technological prowess, ferrying astronauts and cargo to space. But after its retirement, NASA suddenly found itself without a way to send its own astronauts into orbit from American soil. Instead, NASA had to rely on Russia's Soyuz spacecraft, purchasing seats for American astronauts at a steep cost. This arrangement, while effective, was expensive and left the U.S. dependent on another nation for access to the International Space Station. Determined to regain independence and spark innovation, NASA launched the Commercial Crew Program. The idea was bold: partner with private companies, invest in American industry, and let them design and build the next generation of crewed spacecraft. In 2014, after a rigorous selection process, NASA awarded contracts to two companies. The first was Boeing, a trusted aerospace giant with decades of experience, tasked with developing the CST-100 Starliner. The second was SpaceX, a relative newcomer but already making waves with its innovative approach. Their vehicle would be the Crew Dragon. NASA's plan was simple but smart: develop two different spacecraft, so if one ran into trouble, the other could still keep astronauts flying. This redundancy would ensure America's access to space was never interrupted again. Boeing, with its long legacy and deep government ties, received the larger share of funding, reflecting NASA's confidence in their experience and reliability. SpaceX, the ambitious upstart, got less money but quickly proved its ability to innovate and move fast, pushing boundaries with new technology and a fresh mindset. In 2020, SpaceX made history by launching its first crewed mission, returning human spaceflight to U.S. soil for the first time in nearly a decade. It was a triumphant moment for NASA and the nation. Boeing, however, faced a series of technical challenges and repeated delays. Each setback pushed their first crewed launch further into the future, raising questions about the program's balance. As the world watched, NASA's two-provider strategy was put to the ultimate test. The long-awaited Starliner crewed flight became a symbol of perseverance and high stakes. The stakes couldn't be higher. America's independence in space and the future of its space program depended on both companies succeeding, not just one. As SpaceX soared to new heights, Boeing continued to struggle, working tirelessly to get Starliner off the ground and prove its worth. The future of U.S. spaceflight now hangs in the balance, hinging on whether both companies can ultimately deliver on NASA's big plan for American astronauts to reach the stars, on their own terms. And on June 5, 2024, Boeing Starliner finally launched with astronauts Butch Wilmore and Suni Williams. The mission was Starliner's big test fly to the ISS, dock, and prove it was ready for regular flights. But soon after launch, problems appeared: persistent helium leaks in the propulsion system. As Starliner neared the ISS, 5 of its 28 thrusters failed, threatening the docking. The astronauts and ground teams scrambled, managing to recover some thrusters and dock safely. Despite reaching the ISS, Starliner's flaws were exposed: critical leaks and unreliable thrusters. The mission meant to last 8 days was suddenly in doubt. NASA and Boeing faced a tough question. Was Starliner safe enough to bring its crew home? The answer would take weeks to determine. NASA and Boeing discovered helium leaks in Starliner's propulsion system. Alarms went off across mission control. Helium may seem insignificant, but in the vacuum of space, even a tiny leak can spell disaster. The news sent ripples of concern through both organizations, as the safety of the crew and the success of the mission suddenly hung in the balance. Helium is essential for pushing fuel into the thrusters. Without it, the spacecraft can't steer, maneuver, or return home safely. It's the invisible force that allows astronauts to control their ship, dock with the space station, and eventually make the critical journey back to Earth. Without enough helium, the Starliner would be left adrift, unable to perform even basic maneuvers. Engineers quickly got to work tracing the source of the problem. They found not just one but 5 separate leaks, one that was already known before launch and 4 new ones that appeared while the spacecraft was in orbit. Each leak added a new layer of complexity and urgency to the situation. The discovery of multiple leaks suggested a deeper issue, possibly a fundamental flaw in the design or manufacturing process. This wasn't just a random failure. It hinted at a systemic problem that could threaten future missions as well. With helium steadily escaping, every hour spent in space increased the risk for the astronauts. The crew had to monitor the situation constantly, knowing that their ability to return home depended on a dwindling supply of this crucial gas. The thrusters required full helium pressure for undocking from the space station, and for the fiery re-entry through Earth's atmosphere. But with the leaks ongoing, no one could guarantee that enough helium would remain when it was needed most. The margin for error was razor thin. What made matters worse was that a similar leak had occurred during a 2022 test flight. At the time, engineers believed they had fixed the issue. Now, the problem had returned. Only this time it was more severe, raising serious questions about the spacecraft's reliability. With no immediate solution, the crew's return to Earth was put on indefinite hold. Engineers on the ground worked around the clock, analyzing data and searching for answers, while the astronauts waited anxiously aboard the International Space Station. The reliability of Starliner was now under intense scrutiny. As the days stretched on, the astronauts' stay on the ISS grew longer than planned, and the world watched as NASA and Boeing raced to solve the crisis. The mission's success, and the crew's safe return, now depended on solving a complex engineering puzzle, 250 miles above Earth, with time and helium running out. Starliner's thruster failures during ISS approach raised the stakes. The RCS thrusters are vital for docking. If they fail, the capsule can't safely connect or maneuver. 5 thrusters stopped responding, forcing the crew and ground teams to reset systems mid-flight. 4 thrusters were recovered, but the incident exposed a critical vulnerability. Investigators suspected the helium leaks and thruster overheating were linked, revealing a complex design flaw. In space, there's no room for error, especially near the ISS. Starliner's propulsion system was not ready for prime time, and NASA's focus shifted to astronaut safety. Starliner's 8-day mission turned into months as technical problems mounted. Wilmore and Williams, meant to be test pilots, became long-term ISS residents. NASA and Boeing ran endless tests, but couldn't guarantee a safe return in the faulty capsule. The ISS crew schedule was disrupted, and the astronauts' stay kept extending. In September 2024, NASA made the call. Starliner would return to Earth empty, the capsule undocked and landed autonomously, gathering data but failing its main test. Wilmore and Williams waited for a new ride home, their mission transformed by Starliner's flaws. The dream of 2 reliable U.S. crew vehicles was suddenly in jeopardy. NASA faced a hard truth. Safety comes first, even if it means changing plans. With Starliner grounded, NASA turned to SpaceX's Crew Dragon to bring Wilmore and Williams home. Crew Dragon, already proven and reliable, became NASA's only option. The astronauts waited months for the next available SpaceX flight. In March 2025, they finally boarded Crew Dragon for a smooth, uneventful return. After 9 months in space, they splashed down safely, rescued by Boeing's competitor. The incident cemented SpaceX's role as NASA's primary crew transporter. By then, SpaceX had flown dozens of people to orbit, while Boeing struggled with its first crewed flight. NASA's 2-provider dream was on hold. SpaceX was now the sole U.S. crew launch provider. The Starliner saga showed just how hard it is to build a new human-rated spacecraft. For now, NASA's hopes rested on the Dragon. Starliner's failure rippled through NASA's astronaut corps and ISS schedule. Astronauts assigned to Starliner flights were suddenly in limbo, their training and missions upended. NASA had to reassign crews, moving experienced astronauts like Mike Finke to SpaceX flights. Switching vehicles meant months of retraining and logistical headaches. The ISS relies on a steady flow of crews. With only one provider, any SpaceX delay threatened station operations. The safety net NASA built with 2 vehicles was gone. The agency was back to depending on a single system, just like the old Soyuz days. Every SpaceX launch now carried even more weight. NASA's commercial crew program was built on redundancy. 2 different vehicles, 2 companies, no single point of failure. Dissimilar redundancy meant a flaw in one wouldn't ground both. The Starliner crisis proved the wisdom of this approach. When Boeing stumbled, SpaceX stepped in. Without Crew Dragon, NASA would have faced a dire choice: risk a faulty Starliner or leave astronauts stranded. The incident showed why 2 providers aren't a luxury, they're a necessity. NASA remains committed to having both Starliner and Crew Dragon flying. Relying on one provider, no matter how reliable, is risky. As the ISS nears retirement and NASA looks to the moon, multiple crew vehicles are more important than ever. The Starliner setback was painful, but the logic of redundancy remains unshaken. America's leadership in space depends on more than one way to get there. As of July 2025, SpaceX stands at the forefront of U.S. human spaceflight, preparing for its 19th crewed mission, a remarkable achievement that cements its role as a leader in the new space age. The company's relentless pace and reliability have made it the go-to partner for NASA's most critical missions, and its launches have become a symbol of American ingenuity and ambition. Crew Dragon is now the backbone of NASA's operations to the International Space Station. With contracts extended well into the future and confidence in the spacecraft at an all-time high, NASA relies on SpaceX to keep the ISS crewed and supplied. Each successful mission strengthens the partnership and sets new standards for commercial spaceflight. Meanwhile, Boeing Starliner faces a challenging path. After years of setbacks, the spacecraft is undergoing extensive ground tests and critical redesigns. Before astronauts can safely board again, another uncrewed flight is likely required. The road to recovery is long, and every step is under intense scrutiny from both NASA and the public. Boeing's delays and cost overruns stand in stark contrast to SpaceX's rapid progress and repeated successes. The difference is clear. While one company soars, the other remains grounded, working to overcome technical and organizational hurdles that have slowed its journey to the stars. Yet, despite these challenges, NASA's vision depends on Starliner's success. Having two operational vehicles is not just a luxury, it's a necessity for safety, flexibility, and the future of American spaceflight. Redundancy ensures that no single setback can halt our progress or leave astronauts stranded. The next era of space exploration is on the horizon. Missions to the moon, the construction of private space stations, and journeys beyond low Earth orbit will demand multiple reliable spacecraft. The stakes are higher than ever, and the need for innovation and resilience has never been greater. The story of Starliner and Crew Dragon is about more than just two companies competing. It's about building a robust, resilient future in space, one where collaboration, competition, and shared ambition drive humanity forward. For now, SpaceX carries the torch alone, shouldering the responsibility of keeping America's space ambitions alive and thriving. But hope remains high that Boeing will soon join them in orbit, fulfilling NASA's vision of two strong wings lifting America's dreams higher than ever before. The journey continues, with every mission teaching new lessons and the stakes for the future of space exploration growing ever higher.